how many of you know what open source is or heard that term before? All right, good. Last time I gave this presentation, no one did, and it was a little uncomfortable. So, there we go. It might start up. We'll see. There we go. All right. So, for those of you who raised your hand, but you actually don't know, you just don't want to feel left out, the idea of open source is that rather than hoarding all my source code away from everyone else, I put it online, and I even say, hey, if you can improve on this, submit code, and I'll incorporate it. And a lot of software that we use runs on this. So for example, anyone use Blender? Open source, right? Anyone use Krita? Open source. Firefox, Linux, tons of things are open source. So AI is being incorporated in a lot of commercial products, right? Anyone use Photoshop? Yeah, of course. So a lot of commercial products, a lot of monetization there. For example, things like Adobe Firefly is one of their big pushes to incorporate generative AI into artist development processes. But there are some concerns. For example, oh, gotta stay here? All right, my apologies. I like to walk the stage, as some of you who are my students know. I'll try to minimize it. So for example, do we know where that data comes from? Adobe was kind of cagey about it, but they finally admitted that they pulled some of it from Adobe stock and some of it from Midjourney, which they didn't want to admit. So there's concerns about data, especially if you want to release something. You may not have the rights to it. There may be some issues, as has been brought up before. You may also be worried about versioning. So if, for example, a while back, Photoshop ran into issues where they temporarily had an issue with a partnership with Pantone, and so people who had Pantone colors opened up Photoshop and they were all black because it had been taken out because it's a cloud platform. So if you're worried about that, which you might be, you may want to have more control over your data. You may also not be able to afford the licenses for more commercial software. And again, ethical and legal concerns. So one of the things I want to talk about today is AI generation incorporation in open source software. So rather than having to rely on commercial software, there are plenty of uses of AI in open source. So these are either built into the applications already, or you can install them via plugins and extensions, right? So you have that option. If you want no AI, then you have that option. If you want to incorporate AI, you have that freedom. One of the benefits of open source, right? Also, you have the ability to review your code and your data sets. So last I checked, I can't look at Photoshop's code, right? I can't verify that it's not doing something I don't want or something that might get me in trouble. But with open source, by definition, I can. I may not actually do it, but I have that freedom, right? They tend to be free or low cost. So again, if you're an indie studio, you're just starting out, or you just at the moment can't afford the licensing, free software, pretty good. Now there are some trade-offs, right? Maybe the usability isn't quite as nice, as polished, but for free, might be willing to put up with that. And also, you can stand in a particular version. So if I want to keep Krita a particular version, I don't have to worry about the owners of Krita saying, nope, cloud platform, you're going to update to this new version that takes out this feature that you use. You can stick on that version. If you really want to, even if they remove it from a future version, you can get the source code from an earlier one, build it, and keep running it as you like. So you have that freedom and that control. Right? I'm not being paid by open source to sell it. I'm just explaining. So here's some common tasks, and I'm focusing primarily on art and art asset generation, but there are obviously for music, for video, similar concepts. So some things you might want to do using AI are image segmentation. So if I have a texture, I have an asset, and I want to change a particular part, I want to be able to very quickly do that. Use AI to specify, oh, this is a person, this is a camera, that's a trash can, rather than having to do color select and other things like that. And there are AI algorithms and tools that are built in that you can use. I might also want to upscale. So if I'm doing a remaster, or if I got a really low quality image, I may want to be able to upscale it without having to redraw it. So there are plenty of non-AI algorithms that do that, but also a lot of interesting AI algorithms that will guess what a larger version should look like. We also have in-painting and out-painting. So let's say that I have this texture that an artist gave me, and now I want to expand on it. I might be able to utilize tools to guess what should be in there. So for example, if I'm only seeing this much, I can use outpainting to guess what the larger space would look like, again, using AI. In-painting is the opposite. If I have something that is, I want to get rid of a particular texture and it's really tightly integrated with the scene, I can use in-painting to fill in the spaces, right? And then obviously asset generation, and there's all sorts of different possibilities there. So I'm going to go over a few of these and just show you some examples in open source of how these are used. Keep an eye on the clock. So I'm going to start off with an older one, relatively, which is the resynthesizer. So this is a plugin for the open source software GIMP, which actually existed before Photoshop's version of it, which they are super proud of. One area they beat them in. And the idea, this was based on a dissertation from 2005. And so the idea is very simple. When I look at an image, rather than just learning boundaries, I can also learn the textures. So for example, those chairs are different colors, right? The seats, but they have the same texture. And so if I learn the textures of these areas and then I see other textures that look similar, I can fill them in, right? And so that's the idea of the synthesizer. It is a very relatively basic algorithm compared to the more advanced ones. It only trains on a single image. So if you're worried about copyright, your synthesizer has no issues. It has no data set other than the image itself. The trade-off is that, well, you can't generate something from outside the image. So if you want to make a frog appear in there and there's no frog, you can't do that because it's not in the training set. But again, if you're doing editing on a texture, you want to clean something up, it can be a useful tool. And so I will go ahead and show you a brief demo of me. This is an image I was playing around with. I incorporated the synthesizer. And so what you will see, just messing around with some of the settings over here, how it pulls the information, looking from the sides, doing randomly. And so we see that I am circling this child because I want to get rid of the child, because I'm a terrible person. And look, they are gone. Magic. Again, so I can run it a few times because I may not like the outcome. It will randomly generate a little bit differently each time. And again, this is not as advanced as some other models because it is only using the data that's around it. So I don't have a large training set, but on the bright side, I don't have to worry about copyright issues. I don't have to worry about I'm training on some data, I'm using some data that, stealing from someone else, depending on how you want to define that. So, all right. So that's an example of in-painting. Now, there are plenty of other more advanced algorithms. So for example, somebody mentioned you used Krita earlier. And so Krita has several plugins that can connect to Stable Diffusion or to local models, which is an interesting point. So rather than pulling from online and having possibly licensing, if I have a local model that I have installed on my computer, I can use that as a source instead. So I have more control over that data. If I've already have a model that's been trained on images that I have the rights to or on public domain, again, I don't have to worry about so much the copyright issues. So these plugins, and GIMP has them as well. Intel has demoed some plugins using GIMP. But they have a variety of features, including the upscaling I mentioned earlier, in-painting that we just saw, and out-painting, as well as asset generation, right? So I'll show you a demo of that I did not do, but I have from the interwebs. So if we look here, and I'll go ahead and turn the volume off because they're not the one talking, I am. All right, so let's see, is it running? It is not. I thought it'd be clever by downloading in advance. It seems, there we go. All right, so kind of hard to see, but there is a prompt over there describing a house, and you see that as they draw, over here, they're generating something based off that prompt, so like a field with a blue sky. And so it's based off the sketch they've drawn here. So they have some artistic control of where the field is, and then they can control the strength of how much it has an impact. And so then we're going to change colors again to a blue sky. And as they draw, we'll see that the image over here fills in with clouds. It goes to a more blue area, creates more of a blue sky field. And then there's a checkbox over there. They're going to do some more coloring in a second to create more of a shiny sunset effect. And then when they're ready, they can click the checkbox to bring the generated image, the generated asset, over to here, which they will do in just a second if I remember this video. They can also alter their prompt, so they can, for example, add information about I want to add a house here, I want to add other assets, with a nice arrow showing it off. So I'm going to give them just another second to show that before I move back to my own part of the presentation, because again, this is supposed to be my talk. And so this can be a workflow if you're generating textures. See, there you go, pass it over. And then again, they will add some information about, now I want to add a house to this scene, or I want to add a house to this texture. And so they'll start drawing over here, and that will generate houses over there, or they can do it automatically. But if you want to have more control, this can be tied in with an artistic workflow. Let me give them just another second. So see, as they're drawing over here, now the house is matching their drawing, right? So there's still some imprecision compared to if they had done this all by themselves, right? But they can influence the generated asset. Now, the trade-off, mentioned earlier that with the synthesizer, no copyright issues. If you were pulling this from a standard data set, you might run into some challenges there, and we'll talk about that in just a little bit. All right. So Blender is another tool that has integrated AI assets. Blender has a lot more funding than both GIMP and Krita, so they have a whole plugin workspace. Some of them are paid, some of them are free. But they have a variety of features, for example, text to texture or to PBR. So if you have a model that you want to generate a texture for, you can type in just like we saw with Krita and generate that texture, play around with it, export it possibly to the art program to do editing or using Grease Pencil or something like that. They also have tools like AutoDepth AI, where if I want to make an environment or scene, I can take an image, pass it through the filter, a 2D image, and make a 3D scene out of it. Now again, as was kind of mentioned in our keynote, you may have to do some work on that, right? With 3D models especially, well, anyone ever done a 3D scan of something and then tried to use it in a game? So is that something right off the bat you can take that? No. So that's still something where it may look right until you look at the geometry and it's just a mangled mess of things. But you have maybe a starting point, right? Other examples that I thought were pretty interesting are a render refiner. So if you have some sort of effect, like maybe a simple halo, you can use Blender AI plugins to analyze that and say, hey, I want to make this more of a multicolor render. I want to do this. So you can play around with your rendering pipelines. All right. So I thought I'd take a pause for a second, because I've talked about all these applications, and I'm not going to go super deep into lecture for those of you who are worried about that, but I do kind of want to give you an idea of how all this works at a high level. So a lot of these image asset generations use something called a diffusion model. And so the idea of diffusion is that I can learn about something in various stages and then reverse that effect and be able to generate it. So let me show you visually what I'm talking about. So let's say I start off, I have this photo, and I've tagged it and I've said, hey, this is a photo of a man on a bike driving through the countryside, right? So in my model, I will do something called adding a little bit of noise. So I will go here, and I'll add some noise. Part of it's covered up, a little more drastically than in real life. And I'm going to relearn it again. I'm going to say, this is still a picture of a man on a bike driving through the countryside with some noise. I'll train it again. I'll put some more noise in there. Notice how the image is becoming less and less immediately visible as a man on a bike. But I'm still saying man on a bike with a certain amount of noise. And I will keep doing this over and over again until eventually Let me go ahead and do this real quick. Eventually, at the end of my training cycle, I will put so much noise in there that it's just that, right? So that's step one. Then I reverse the process. I train it again. I say, all right, I want to make man on a bike. Let me remove a few bits of noise. Let me do that again. Let me do that again. Let me do that again until I get back to my original image. And so what the model should learn, obviously not with just one image, but a whole bunch, is, hey, if I have a random Gaussian distribution just of noise, of random stuff, and I want to make a man on a bike, these are the pixels you remove and change to get this image. And if I do that a whole bunch with a whole bunch of images that are labeled very well, then I can generate assets, right? And so the idea is that if I do this with enough images, it won't be necessarily specifically this man on a bike that I get back. It will be some amalgamation of all the men on bikes driving through the countryside that I have trained on. However, if I only trained on one man on a bike, I'm going to get this exact image back. So that's where some of the copyright concerns come in terms of the data, the image you're getting back out. How much is it like the original image it trained on? I'm not going to be able to solve all those questions today, right? But hopefully at least you have a better understanding of how it works. And again, a lot more math involved, but I won't torture you with that today. Maybe. But conceptually, that's how all of these work. And they're often combined with other models. So for example, just a diffusion model would just be the training, putting the noise in there, getting it back out. Mostly you want to combine it with things like a text image, so it knows if I ask for man on bike, it knows what man on bike is and how to get that back out, right? Otherwise, I've just made this amazingly beautiful picture. So I mentioned image segmentation. Facebook, which was mentioned earlier, has released an open source model called Segment Anything 2. It's open source, and a lot of open source software incorporates this model. And so the idea, again, is that based on a whole bunch of images that it trained on, it can segment, oh, person, gimbal, camera in back, skylight. And so if it sees an image with that and you ask it to segment, it will be able to do that almost automatically. So rather than having to select colors or do masking or something like that. So again, very, very helpful if I'm trying to do some asset editing. All right, so those are already brought up earlier, and I'm going to make some notes here as well. I showed you with the diffusion model potential ethical concerns, right, using copyright data. To train a model, you can't just use one image. I know, that's very sad. It'd be nice if we could. You need a whole bunch of images. You need a whole bunch of data sets, and I don't know about the rest of you. I don't have time to go and draw all those many images to train. Maybe some of you can, in which case you have a bright career in data entry. But so in most cases, we tend to train on existing data sets, right? And that's where the rub comes in. If I use a data set that I'm not aware of, every image that's in it, can I 100% say that I've used only ethically sourced, copyright-free images? I probably can't say that with certainty. In fact, one of the first really big data sets, Leon 5B, was found to contain all sorts of terrible things. It contained, for example, people's medical records, because it just hoovered up the internet. It also contained child porn. So initial models that trained, stable diffusion, things like that, trained on child porn, which means they can generate it. So a lot of concerns, right? Again, I'm not going to say any of that was intentional. Billions of images were needed to do the initial training sets. To get those kind of images without paying someone a whole bunch of money, you kind of have to hoover up a bunch of stuff undiscerningly. Right? So I'm not necessarily saying any one person was evil, but just by the very nature of what they're doing, things like that slip through. Another thing to be concerned about is that oftentimes when companies say that, we only used our own images, what they actually mean is we use an existing data set as a base and then fine-tune on it with our own stuff. 5 minutes? Okay. All right. So that's something to be cautious about. I mentioned earlier, Adobe originally was claiming they only used Adobe stock, and then it came out that actually they had trained on top of Midjourney. So, in terms of copyright, that's still an ongoing thing as mentioned earlier. There have been some early cases settled that are not using generative AI. Router, I think, was one that was trained using an earlier type of rule-based AI, and that was decided in the favor of Router. So I'm saying it wrong, but in terms of the original creators. So far, in the US at least, there has been a tendency to lean towards the creators' rights. We'll see how that goes as the court cases go on. There's still several outstanding. But also studies have been done to show that artists are still needed for high-quality products. I've seen plenty of examples, both as a teacher and working in open source and in game design, of people submitting AI-generated stuff, and then when you look at it for more than a second, you're like, oh, well, there's problems here and there's issues there. So people with that knowledge are still needed to ensure that what's generated and produced is high quality. So again, some relevant cases. Most cases tend to be from 2020 onward. AI existed long before that, but the current generative AI really started becoming well known around then. So again, that was one I mentioned earlier. One of the big art ones is Anderson versus Stability AI in terms of, again, claims about using their images without permission in the training set. That's still ongoing. And then the U.S. Copyright Office one is not so much a court case. It's just this particular person keeps submitting AI-generated comics for copyright, and they keep rejecting it, which is kind of amusing. Essentially, the Copyright Office said, you own the rights to the positioning of the panels, you own the rights to the words, you don't own the rights to the image. So again, that's the current state in the US. Different countries obviously have different rulings. I know in the UK they are having some heated discussion about that. So just something to be aware of. All right, so as I wrap up, just some best practices, recommendations. Know your data throughout the chain. So if you don't know what data you're using, if you're not using a local model, you are potentially at risk, right? And I know that's not easy. That takes some work. It's worthwhile. If you can, also get licensing agreements. So if you are getting data provided by someone else, get a license saying, hey, you're telling us that this data you have the rights to, we can use. That way, if they're lying to you, well, you have signed documents saying, hey, not my fault. And then also just be aware of your tools. So with open source, you can audit your code. I know that's an effort that takes some skill, but that is something you have the option to do with open source. I encourage you to do so. And if you can, run locally. That's not always an option, but again, if I'm running a model locally, I know all the data, I know where it's coming from, pretty much set. So that is my quick overview. Covered several different topics. So now, any questions? Cool. Oh, wow. All right. Usually I make my students do rock, paper, scissors, but I saw you first, so let's go for it. Yes, you.
I guess mine's more of like a rudimentary question. I guess how are you building your own local data?
So that is the rub, right? You can build them with public domain images. So there are plenty of repositories with public domain as a starting point. I can't draw enough images to make a really comprehensive data set, but there are plenty of public domain that you can build off, and then you can use your own work to fine tune. Now again, training a model takes a lot of resources. You can, for example, use Google to train it for you so you can take advantage of the resources. It costs some money. But that would be my recommendation and starting point, public domain. The challenge, again, is that if something's not in the public domain, well, then you either have to draw it yourself or get licensing rights for it. And that can be another approach. For example, some companies who already have a wealth of images that they own, for example, Disney, they don't have to worry about that because they can just license their own work, right? But it's a challenge. That would be my starting point, though. Public domain, something to verify you own the issues, data for, and then build from there. All right. Yeah. All right. I saw their hands. I did. And I saw yours next. All right. I'm going completely off screen, but it's all right.
No problem. Yeah, so my question is, the first part was similar to hers. I think it's going to be really difficult for me to grab a bunch of public domain images off the internet because they're going to be claiming they are public domain too, so that's a problem. What is the current state of open source models that have been properly vetted by the open source community, which has historically done a good job at removing copyright from open source code, for instance?
So I will say that actually a lot of open source code is licensed. So it's a little bit different than it's not that they don't have copyright, it's that they're saying we license it and we're letting you use it for this. However, there might be some restrictions. So I would say that Creative Commons is kind of taking the lead on that. Creative Commons is kind of the open source art licensing model where you say, hey, I've drawn this thing and I am totally okay with you using it for this, this, and this. Not this, but this. So they have been doing a lot of work with trying to use Creative Commons images to build these local models. But again, it is something where it takes a lot of work, it takes a lot of effort, so it is still ongoing. But yeah, ideally, they're the ones kind of leading the charge in that, and so my hope is that as they continue to work on it, we will have these open source data sets that we can use. And again, with the tools I mentioned, they also allow you to use your local models. So if you have built one, you can use that instead. We're on the front here, future of games. All right, other questions? Yes. I should have planned this so I wouldn't have to run so much.
Exercise Saturday. So you focused on 2D images and still images. Do you feel a lot of this applies to 2D animated and 3D animated, especially folks around denoising?
No worries. Yes, so I only had so much time. I would have talked about a whole bunch of stuff if I had more time, which is always the case. But yes, so there is a lot of work being done, for example, on animation and keyframes. And for example, OpenToons is another software that has tools like this for animation keyframing. So I just didn't have time to talk about it. But yes, everyone's exploring it. Blender has 3D model generation. Audacity has various plugins in terms of generating sound. So anyone who's doing open source, there are people, either the official developers or people who are using those toolkits as a starting point to develop those plugins. So, All right. Yes, one more. All right. Maybe one more.
So I guess my question is a little bit multi-part. Okay. So first one is what kind of all goes into making your own local model? Because I know that there's a lot of concerns about the amount of energy that it takes to to train a model. There's whole data centers that exist for that whole purpose. Is it a lot easier to train your own local model, or is it what is that kind of like?
Oh, sure. So anything's easy if you know how to do it. Yeah. Yes, that is a concern that hasn't been brought up, but anything that you train takes a lot of energy. However, it also depends on the number of generations you do. For example, in the research I work on separately from this, we are constantly retraining our models with new data. So we have pipelines where we generate certain data, we then retrain our models, we fine-tune it. Versus if you say build a local model as a starting point, you may run that relatively few times. And you can, even if you have a good enough computer, run it just locally on your machine, and if you're just willing to wait a long time. So in general, you generate a data set, you annotate it. So I say oh, this is an image of man on bike in countryside. And obviously, the better you annotate it, the better results you're going to be able to get, right? If I just say man, I'm not going to get the information about bike or countryside, right? So there are whole jobs involved in people paying you to annotate images for AI training. So you generate your data set with your metadata, and then you pick your model, and then you essentially say, all right, here's my data loader. I'm going to say this many batches, so I might do 10 images at a time, 20 images at a time. I feed it through. I let it go for a certain number of cycles. So I showed you earlier with the diffusion model, it was color, gradually adding and loading. So that might be one epoch per image. I may repeat that process more than one time. I probably will have to, in fact, because I don't want to overtrain it or undertrain it. Essentially get it sorry, I'm getting into teaching mode. I apologize. And so then at the result, I will have what's known as a set of weights. So the model essentially says, oh, if I give it this prompt go through these various pathways, and the weights will say, this one's more important, this is less important. And so that will be combined with the actual algorithm to say, hey, to generate this kind of image, do this, versus this image, do this.
And
So
at that point, it's just general neural net stuff.
yeah, yeah.
Okay.
So yeah, once you the weights are the important part. That's the end result of your model training. And so if I want to draw in the style of Picasso, that would be one set of weights. If I want to draw in the style of, I don't know, Garfield, then that's a whole different thing, right? Okay, and I think I've run over my time. So, oh, have I run over my time? Okay. Well, all right, let's run over here. No, I did it for everyone else, and I don't want to single you out, I do. All right, so ask your question again.
Yeah. So what kind of hardware do you recommend for training a model?
So you'll need something with a GPU, not like an integrated one like you get from like the Walmart computers, because that's really, really important. With a GPU, with a CPU, I have to do everything one at a time. I can do a lot of complex stuff, but I do one at a time. With a GPU, I can say, hey, every one of you do this one simple thing and get back to me. And so rather, that allows me to do things very quickly. So if you get some GPUs, you can compensate. But in general, if you have a little bit of funding, use Colab or something like that, where you can just say, hey, Google, you have a whole bunch of stuff. I don't have to buy this hardware. I'll pay you a little bit of money to run my model and do it for you. All right. I'll let them have their mic back.
Thank you so much.